Welcome to an Achieving Science video. This video is going to look at acids and alkalis. First of all, in a science laboratory we will come across lots of acids and alkalis. They are colourless solutions and therefore we need to be able to tell them apart. For this we use what we call an indicator, such as universal indicator. Its scale is shown on the screen. When we add universal indicator to the solution, we find that there is a colour change. And this colour change can determine and show us whether it is an acid or an alkali. The common acids that you're going to use within a laboratory then include hydrochloric acid, sulfuric acid, and nitric acid. It is also useful to know the formula for each of these acids. So hydrochloric acid has the formula HCl, sulfuric H2SO4, and nitric acid HNO3. If you look carefully, you'll notice that all acids therefore contain the hydrogen as a H plus ion. This makes them all acidic. Now let's have a look at the alkalis that you're tending to use within a laboratory. The main ones that you tend to use include sodium hydroxide, potassium hydroxide, and calcium hydroxide. And again, let's have a look at the formula for each of these. Sodium hydroxide has the formula NaOH, potassium hydroxide KOH, and calcium hydroxide CaOH2. Again, the similarity is that they all contain the oxygen and the hydrogen ions, the hydroxide ion, OH-. This makes them all alkalis. Now when we react an acid and an alkali together, we have a neutralization reaction. We can summarize this in a word equation. Acid plus alkali produces a salt plus water. Now we can look more carefully now at why water is formed. We have seen that all acids contain the H plus ion. All alkalis contain the OH minus ion. We add these together and we get 2 hydrogen and 1 oxygen, i.e. water, H2O. Now within a laboratory we'll come across acids which are strong and acids that are weak. We need to know, well, what's the difference between them and why are they different? Well, the difference is that acids ionize in water produce the H plus ion. That means they separate, they divide. Ions are charged. Strong acids fully ionize, they fully separate, e.g. hydrochloric acid and sulfuric acid. On the other hand, weak acids do not fully ionize, and instead they'll form an equilibrium mixture. This includes acids such as ethanoic acid. So in terms of the pH scale then, why did we get that colour change? Well, we get that colour change because at the same concentration, strong acids have a lower pH, i.e. a pH of around 1 to 3. This is because there is a higher concentration of H plus ions.